Okay, guys, we'll start. Today we'll be talking about Java, very basics of Java, but I'll be addressing you as Flex developers, assuming that you don't know Java at all, and I'll try to cover, I don't know how much time will I spend, between hour and a half and 2 hours, something like this. I will try to give you some basic understanding of the language and what can be useful for us if we are Flex developers. So this is a presentation, this is a part of our Princeton JOG and New Jersey Flex joined meeting. First time I run it online, but I've been running online other meetings, so we should be fine in this area. Probably you know I work for a company called Farata Systems. We are working with all these different technologies, Java and Flex and Flash and HTML5 and e-commerce for Hybris, and Hybris is actually a software. So we are a consultancy. So that's enough of a marketing, and now let's go to the meat of it, to Java. I'm going to be using examples in this presentation from my book that was published last year, Java Programming 24-Hour Trainer. And I'll show you the site where all the examples are. I'll be downloading a couple of samples, but you will see where you can get all these examples. I'll show it to you later on. So let's start from the beginning. Terms: Java, JDK, and JRE. Java is a compiled language, of course, and there are two sets of software that you may have on your machine. If you are a developer, you need to have JDK, Java Developers Kit, JDK. If you are planning to run Java program written by someone else, you don't need JDK, but you need JRE. So JRE is basically a runtime environment, Java runtime environment. Current version of Java is version 7. Sometimes you can read in the books 7, sometimes you will see references as Java 1.7, it's the same thing. And JRE is basically a JVM plus some other libraries. If you are Flex developers, you understand the concept of running inside the VM, virtual machine. In case of Java, we are talking about JVM, and in case of Flash or Flex, we also need a VM virtual machine. But in that case, we are not talking about JVM. We are talking about Flash Player. Flash Player is a VM. As a matter of fact, Flash Player has inside 2 VMs, but let's just say that it's a VM for ActionScript 3. This is what matters for us today. Java has two sets of, how would I put it? Two distribution versions. You can say I want to have Java SE, or you can say I want to have Java EE. SE stands for Standard Edition, and EE stands for Enterprise Edition. I'll tell you closer to the end of the presentation, I'll tell you about what is Java EE, what's included in there, and so on. For now, let's leave it as that. So to write Java programs, you need Java SE. To write Java programs using different technologies, typically server-side technologies, as you see in the middle, third bullet, if you want to use Java servlets or Java server pages or EJB or Java messaging, all these things are included in Java EE. So let's start with Java SE, Standard Edition. Java, when you write Java program, Java is compiled pretty much similar to what happens to ActionScript. ActionScript is compiled into a bytecode, and Java is compiled into a bytecode as well. Java is not compiled into machine code, which makes it cross-platform enabled, so to speak. When you write a Java program, your Java program will always be executing inside of the JVM, Java Virtual Machine. Java compiler will compile it into a bytecode. Bytecode will be loaded inside this JVM, and just-in-time compiler, so-called just-in-time compiler, which ActionScript also is using, not ActionScript, Flash Player is applying, I'd say. Java just-in-time compiler will finish the compilation for a particular platform where the program is running. But the big idea is that you run the program which will be will run actually inside the same JVM, regardless of you're running it on Linux or Windows or Mac OS. Technically, you don't need IDE to create, compile, and run the program. And this is basically what they say about Flex as well, right? They say you don't need to purchase anything to write Flex program. Just download Flex SDK, and you have command line compilers like MXMLC, or for libraries compc, and you get any text editor you want, and you're set. And you can generate Swift. The same thing true for Java. And it's true for Java, and what else you can say that, I mean, comparing Java and Flex again, you need to have a text editor. Say you have a notepad, you can type it in, hello world.java, then you can save it, then you can go to command window and apply compiler. Compiler is Java C. In Flex is XMLC, in Java it's Java C. You would compile this program, hello world, for example. The source code is having a name extension Java. And if you don't have any errors in your program, it'll create a file called hello world.class. If you generated this class, it means that your program compiled fine, and this is a bytecode. So this is basically an equivalent of Swift, so to speak. And then what you need to run it. To run it, you are starting JVM. Again, we are in the command line on this slide. JVM using this Java space and the name of the program. So your operational system will start VM first, and then it'll load inside your hello world class. So you can do all this from the command line. Usually developers are using some kind of an IDE, which is true for Flex developers as well. And what is this IDE? Eclipse. Eclipse is probably the most popular IDE. It's not the only IDE, but it is the most popular IDE. Eclipse IDE is free, and it's, I would say, probably like 80 or 90% of all developers are using it. Some people are using IntelliJ IDEA, which is produced by the company called JetBrains. Some people are using NetBeans. IntelliJ IDEA is not free, even though they have Community Edition free. Excellent IDE, and Oracle offers free IDE called NetBeans. Not too popular. Not too many people are using it. So mainly you would be using Eclipse. Since you are Flex developers, I would assume that you feel comfortable inside a Flash builder, which is nothing else but an IDE built on top of Eclipse. So now we're going to be using Eclipse. In today's presentation, I'm going to be using Eclipse. Speaking of Eclipse, which Eclipse you need to download? If you will go to eclipse.org, there are several versions of Eclipse, and what I usually use and what I highly recommend you, again, if you will become a Java developer, and if you will work on mixed projects, Java and Flex, I would recommend you to download Eclipse IDE for Java EE developers. This is exactly the way it is called over there at eclipse.org. Eclipse IDE for Java EE developers has better packaging, I would say. It has more plugins, and in particular, it has plugins for development or for creation of web applications. And this is what we want to do, of course. We need to understand how to do this. And in particular, if you'll be working with mixed Flex Java projects, and especially if you will be working with Blaze.ds or LCDS installed on the server side product from Adobe, they would need to be installed under the Java server. And in that regard, this IDE will be really helpful. So you will install Eclipse, which is zip file. You will unzip it on your disk, and this is pretty much it. You started and you're set to go. I would assume that by this time, when you are downloading Eclipse, you already have downloaded Java development kit separately. Again, similarly, you would need to have installed Flex SDK, right? If you'd be using Flash Builder, or if you want to, actually, to be honest with you, if you want to have a flexibility of saying I want to use this Flex SDK or that Flex SDK, so you would need to download it separately and point your IDE to that SDK. All right, let's move on. So next comes Hello World demo in Eclipse IDE. So what I will do now, I already started Eclipse, and what I will do, I will create in front of you Hello World project. I want you to look at the top of my Eclipse. On the right hand side over here you see different perspectives. At this point I was doing something with JavaScript, I was debugging something, I was working with the Subversion SVN, and that's why you see all this perspective. If I wanted, I also installed here the Flash Builder as a plugin for Eclipse, not as an independent program, but as a plugin. So I could have opened it over here by clicking on this little plus sign on top. Other, see here, you have Flash Debug. If I would do this, I could have opened the Flash Builder perspective, basically to have everything under one roof. See? It's a trial version. That's okay. That's okay. All right. So I can have everything under one roof under Eclipse. I don't need it for this presentation. I'm not going to be doing anything in Flex today. But I'm just saying that we have an environment, Eclipse, which we can use for development in Java and in Flash and in something else. Since I installed Eclipse for Java EE developers, I also have a perspective called Java EE. And we'll be using it a bit later, probably at the end. I'll show you something. But anyway, so to create a simple Hello World, I don't need anything else but Java perspective. Similarly to Flash Builder, I need to create a project. File, new. In this case, I'm going to be creating Java project. Java project. Give it a name. Say hello. And that's about it. In the middle, you can see Java runtime environment. It asks me, actually it uses the default environment that I have on my machine. I have Java SE 1.7 installed, right? So it assumes, do you want this to use? If I would need to create my program that is compatible with older version of Java, I could have selected 1.5, for example. If for any reason my client forces me to be compatible with older version. In that case, it would ask me to configure and tell Eclipse where exactly is your Java 1.5. I'm not going to be changing anything in here, so let's keep it as it is for our super complicated Hello World program. Next. See, it already created a project on the left. Now it creates the structure for the project. Where do you want to put source files? It suggests src directory. Where do you want to have compiled classes? It suggests bin directory. I'm not going to change anything. Pretty much very similar to what you have in Flex. Finish. Done. I got the project on the left, which is hello project, and I have src and I have bin directory. Right now I'm in the navigator view. I can go to package and see it similarly to what you have in Flash Builder as well. Actually, in Flash Builder, you also can open the view navigator. Done. Next, I want to create a new Java class. Right-click on src new. I don't go into detail because it's pretty much similar to what you are doing in Flash Builder, so there's no need to go through every little detail. So what I want to create a new class. New Java class. Everything is in classes in Java. You have to have a class. What is the name of the class? Let's say hello world. Hello world. And in here it also asks me, do you want to generate for you something? It asks me. And in particular, there is a special method called main. This is a method signature. See this? Public static void main and with arguments. If you want a class to be runnable, it's like a starting program for your project. You want to have it. You want to give it a method main. If you don't need it, you may have a project with 50 classes. Only one of them will have the method main, the one that starts the whole thing, and the rest don't need it. Also, packages are similar to what you know about ActionScript. I could have created a package over here, but I won't do this. Finish. Just press the button, finish. See, it created for me the Java class, hello world, with one method, main. So this is main method. So what I want to do, I want to print hello Princeton jog and a New Jersey flex. Actually, you are not Java developer, so let's greet only New Jersey flex portion of our meetup. So inside this main method, what I will do, I will print system out, the same help, context sensitive, system out println. Now I'm doing this system out println, and inside I will do hello New Jersey flex. System out println is a way to print something on the system console. In ActionScript, the closest analogy I can think of is trace statement in ActionScript. But the difference is that in ActionScript, this trace statement works only if you're running in the debug mode. But system out println runs always, regardless if you're in debug mode or if you're not. Now check this out, the same idea. If I have it not saved, I have this little star on top, Command S or Control S, depending on which system you are using. I saved. When I save it, it gets compiled. And run it. Right click on Hello World. Run as Java application. Same idea. See it down there? Hello New Jersey flex. Congratulations, guys. We just finished the first Java program. Hello World. And if you will go to Navigator view, if you care, if you will open up this bin directory, you'll see that it did create hello world.class. Let me make a mistake. Let's say I forgot to put semicolon at the end. It showed me the error. I do Command S or Control S, saving it. It doesn't like it. Go to the problems view, and it shows me syntax error and so on. So I have to compile it. I have to fix it before I can compile it. It gives you such a great feeling, especially after you are writing something in JavaScript. They don't care. You don't have help of compiler there, in most cases. So, get back to our slides. If you guys have any questions as I tell you these stories, type them in your chat room. I have 2 monitors, so I keep my eye on that chat room, so I'll try to answer your questions as we go. Variables and constants. In Java, as opposed to ActionScript, you don't use the keyword var, no vars. You declare a variable by putting the data type first, and then the variable name. See, in this case, it's int primitive integer, or next line primitive boolean. And also, if you want to create a constant in Java, it's technically a constant. It's a final variables, as they call them. You can assign the value only once, but you can never reassign it later on. So you use the keyword final. Pretty much similar to what you have in ActionScript. Method signature. Here's the difference. In ActionScript, you would put the return value, if any, or void at the end of the line. But in here, you start with it. This int, if the method returns integer, then you say int and then the method name. Then you code, and the rest is pretty much similar. And in the green box, you see how you can call a method if you have a method with 3 arguments. So far, it's pretty similar. Java classes. Java classes are very similar to what you see in ActionScript. ActionScript also has classes, right? In this example, let's look at the right-hand side in this pink rectangle. Class car has a couple of properties: color of type string, and integer number of doors, and a couple of methods. Start engine, stop engine. I can say that that both of these methods return nothing. This keyword void in the beginning means that these methods don't return anything. And also, on a similar note, we have a situation when I've declared a variable int temp counter inside the method stop engine, which makes it local. You can use it only inside this method. On the right-hand side, I have another class which will be calling or using our car class. Say I have a test class. Remember, to run a Java program, you have to have somewhere a class with a main method. This is a bootstrap, so to speak. This is something that will start the whole thing. Now on this slide, I have an example with 2 classes. The first one is called test car, and the second one is called car. So in this example, on the green, I create a couple of instances of cars, and I declare a variable car1 of type car. Again, a bit different comparing to ActionScript. You'd specify first the data type, which is car with capital C in my case, and then the variable name. Java is also case-sensitive language, so you have to be careful with that. In this example, I created a couple of instances of car, and I assigned, for the first car, I assigned the color blue. For the second one, I assigned red. And in the end, I just do again system out println. The cars have been painted. That's it. Not rocket science. Easy, 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 easy. Inheritance, the same exact thing as in ActionScript. Actually, Java was first, so let's be nice and say that ActionScript implemented the same thing as Java. It's not all the way around. So in this case, I have on the left, I have class text with several variables, class member variables, gross income, state, and dependence, and a function, or we call it a method, right? In Java, you cannot have a function separately outside of the class. No such thing. So in Java, we have only methods. Caltax is a method, and I just put return 1234.55. But of course, you could put some business logic in there. Say I want to create a descendant, a subclass of NJText. I'm using the same keyword, extends text. And in there, I can add some more stuff that I think maybe in New Jersey we have some adjustment for taxes if you have students in your family or something. So inheritance works the same way. Abstract classes. This is something that you don't have in ActionScript. Abstract class is a class that has a keyword abstract in front of it. That's basically a definition. If you have an abstract class, you cannot create an instance of it. And you can say, are they stupid or something? Who needs a class if you cannot instantiate it? And I'll explain why. If you are designing some application, some program, and if you believe that you want to implement certain methods, but some of the methods you want to be implemented in descendants, then you create, so to speak, unfinished class. For example, we can have a situation when you have employee class and constructor. Both of them are subclasses from person. Maybe you can implement some functionality inside the class person, like, for example, change address. The method change address is the same for constructor or for an employee, correct? But There could be some methods which must be implemented differently for employees and contractors. Sorry. For example, increase pay. If you want to increase pay for the employee, you would increase salary, right, by certain percent. If you would want to increase pay for a contractor, you would increase hourly rate, for example, right? So what we do here, we mark this method as abstract. There is no body in this method, just the method signature. And until one of the descendants will implement this method, increase pay, you will not be able to instantiate a class. So certainly we can create a couple of classes. One of them would be employee extends person. The other would be a consultant, for example, extends person. And we would implement method increase pay, applying different logics in there. So this is something that is unusual for you guys. Let's look at this example. Let's say we need to write a program that would promote workers. This is a spec of your project. A company has employees and contractors. Design classes without using interfaces. By the way, interfaces are the same, technically the same as in ActionScript. So design the classes to represent people who work in this company. And the classes should have these methods: increase pay, give day off, promote, change address. And promotion in our example means giving 1 day off and raising the amount of the paycheck. So change address, as I said, we can implement. It's the same for everybody. Give day off, probably we can also implement. But promotion would be calling probably give day off and increase pay. Increase pay will be different for employees and consultants. So we will make it abstract, right? So I'm just trying to give you a reason to create an abstract class. I'm not saying that it's the only way to design these kind of the program to this spec, but I just want to explain you abstract classes just real quick. So in that case, I can create this class, abstract public class person. See, we have a constructor similar to ActionScript. We have getter, get name, we have change address. All these methods are implemented. Give day off. See, I made it private. Very similar to ActionScript, by the way. Public, private, protected. The only thing is that if you don't put anything in Java, actually the same as in ActionScript, I think. If you don't put anything, any data access variable, it will be package access level, right? So I made this give day off private because it's going to be called from within the method promote only. Promote method calls give day off and increase pay. But I want to implement increase pay differently. So I marked it as an abstract class. By doing this, I'm forcing developers who will be implementing this descendants to use the same exact signature for increase pay, but different logic. Say I am a super duper senior architect, and I have a couple of developers on my team, Mary and John. So Mary will go and develop the subclass for employee, and John will develop a subclass for contractor. But think about it. I am, in my method promote, I am using already increase pay. I mean, literally, I'm using it. I'm not calling it yet because I cannot instantiate person, but I assume that by the time John and Mary are done with their descendants, the object can be instantiated and this method will work fine. Can be invoked. Now, interfaces are similar to ActionScript. Actually, there is a slight difference. In Java, interfaces can contain only declaration of the methods and final variables. I don't think you can use final variables inside the interfaces in ActionScript. So, for example, to implement what we just went through using interfaces only, I could declare an interface payable, for example, payable, with the method increasePay. And I can say that class employee implements payable, maybe something else, promotionable, and so on. Class constructor implements payable. Difference between implementing our project using abstract classes and interfaces. In case of abstract classes, I can partially implement some functionality in the abstract class, and then the descendants will only add the functionality that was not implemented, was meant to be implemented later, was marked as abstract. In some cases, you have no chance to extend any classes. Maybe your class already extends a class. So there is no way you can use abstract classes. So in this case, you're going to have to use different technique by declaring interfaces and saying that class employee and constructor implements this interface. It's very similar to what you have in ActionScript. If any questions, guys, type it in. Casting. Casting has a little different syntax. When I was learning, when was it? 6 years ago, I think, when I was learning ActionScript, I was surprised I couldn't get it. How does it cast it? What does it mean? The syntax was different, and I'll show it to you on the next slide. But meanwhile, you understand the why we need casting. Everything is a subclass of an object, similar to ActionScript. And if you want to have an array, for example, as in this slide, I have an array called person that is capable of holding 100 objects in there. And I put in this array a couple of employees and one constructor, right? New employee, new contractor. And since I declared the array as person, and I assume that employee and contractor are subclasses of person, this is valid. I can put subclasses into an array that is capable of holding superclasses, person. This is called upcasting. It's done automatically. It's similar to what you see in ActionScript. But if you want to write a loop, in my case, I have a situation when the array person, has both employees and constructor, right? So I want to run a loop, and I want to check if I have an employee, cast it to an employee and do something, or if I have a contractor, cast it to a contractor. So check this out. So this is a bit unusual for you if you are ActionScript developer. So in ActionScript, you would have written over here, employee and parentheses would go around workers I. But in Java, you are putting a data type to which you want to cast an object first. So this line means take an element of workers I and cast it to employee. Or later on, there is take an element of type of workers and cast it to a contractor. We call it downcasting. It's pretty much similar, but the syntax is a bit different. That's all. Now I'll show you a quick demo of these abstract classes that we just covered, and I'll show you how you can repeat this on your own. Not now, not during this presentation, but later on if you want to. See, at the end of this slide down there, I put lesson 7, which means that you will need to download the lesson 7 from my book, and it's available over there. Look at this. You go to Wiley, actually it's WROX on the book, but it's Wiley's subordinate or something. So this is the site for the book, and they have a section downloads. In here you have all the source codes for these examples. So if I have lesson 7, so you can download it. See, download it over there. Look down there. I downloaded this example. It's a project. It's an Eclipse project. I go back to Eclipse. right click, import, and I want to say existing project into workspace. It's in the general section. Which one you want to import? I want to import from archive. It's in a zip file. Browse. I want to do this lesson 7 .zip. Let's take one of these. I did it so many times. Oh, they already exist in there. Lesson 7 already exists. Okay, let me kill it. I have it in users Wi-Fi in workspace. Let me do it real quick. Documents. Where is this? Workspace. It's over here. Lesson 7. Let me delete it. I have an old piece. Right click, import, existing projects, next, archive, lesson 7 .zip. Finish. Alright, so I imported this code, and it has a couple of examples for these employees and contractors. Contractor.java extends person. See that? Person. Person is abstract. See that? The class is abstract, and down there, line 33, you should have this increase pay abstract not implemented method. So on the other hand, I have employee.java extends person, and in there I implement increase pay. By doing this, I make sure that the class can be instantiated. And in the constructor, I do the same thing. Different logic, but I implement the method with the same signature. Test pay increase is a starting program with the main method. See, I have an array person. I put in there employee, contractor, employee, and I run a loop calling a method promote. Method promote was declared in the superclass in the person. Let's look at it. Method promote supposed to call give day off. It'll print promoting worker, give day off, and then it'll call increase pay. In a loop, we're gonna be calling increase pay either on employee or on contractor. On contractor, I put on purpose a cap. Increase cap is defined in a superclass. I don't allow to increase salary for more than 20% for a contractor. Not salary, sorry, hourly rate. And in this class test pay increase 2, what I do, I'm trying to give 30% to everybody. Let me run it. Right click, run as Java. Let's look at the console. Promoting a worker, giving a day off to John. John was the first employee. Increasing salary by 30%. Good. Promoting a worker, giving a day off to Mary. Sorry, Mary, see, Mary is a contractor. Mary can't increase hourly rate for more than 20%. Person name is Mary. Promoting a worker, Steve, it's fine to increase by 30%. So you can see that I put everything in the same array, but based on the actual type of the object that is sitting there, different method is being called. Do you have any questions so far? Please type in, if you don't have any questions, please type in at least no, so I can see that you are there alive and not sleeping. All right. Okay. Let's continue. Yeah, I see that you are alive. Let's go back to the presentation. Polymorphism, a little thing. You can do the same thing, of course, in ActionScript. Let's say we have employee and contractor, which are not abstract classes, but just classes that implement payable interface. This interface declare a method increase pay, nothing else. You wrote these classes, you implemented increase pay differently, and what I will change comparing to the previous example, instead of defining an array of type person, like concrete class, I'm declaring an array of type payable, of type interface. I say new payable, which basically means I'm creating an array that is capable of holding references to 3 objects that implement payable interface. Then I create a new instance of employee John and contractor Mary and employee Steve, and they go in that array. And check this out. This is for each loop in Java, and I write for payable P. I'm using only interface data type in here, and I say p.increasePay. No casting, no instance of nothing. I am basically using interface notation. You can do exactly the same thing in ActionScript, if you wish, of course. I'm not going to be talking about UI because you're UI guy, so you will be using Flex or Air to access Java. But if you would be pure Java developer, you would be creating a Java UI. I'm not talking about web. I'm talking about Java UI using Swing library, which is pretty rich library for UI components, or the modern wrapper, so to speak, for the Swing is called JavaFX. Slides will be available, Randy, so you don't need to worry about it. Of course, slides will be available at the group site. All right, exceptions. In ActionScript, your life was easy. It was up to you to process exceptions or to not process exceptions. Not anymore. In Java, there are 2 types of exceptions. In the hierarchy of exceptions, at the very top, you have something called throwable in Java. And it has 2 subclasses, exception and error. Whatever is a subclass of exception must be handled in your code. How to handle the same way as in ActionScript. Try, catch. Try, catch block. Throw, throws. Same thing. If an exception is happening or may happen in your program that is a subclass of error class, don't worry about it. You don't have to catch it. This is something that you can't fix during the runtime. For example, there's no memory in your VM. The program crashes because there's not enough memory. So nothing you can do. But say you're reading a file from disk. Something can go wrong and the I/O exception can be thrown. So if you're trying to read a file from the disk and you must, the Java compiler won't let you get away without putting your code inside try-catch block. You must process I/O exception. If you want, you can declare your own custom exceptions, such as love failed exception, if you want. But just think about it, that there is something called checked exceptions. Whatever comes from or originated from exception class must be processed, must be handled. Collections. Tons of different collections in Java. They are sitting in 2 packages. One of them is Java Util, and the other one is Java Util Concurrent. Java Util Concurrent, as you can guess, has collections which are specifically fine-tuned, so to speak, for a situation when you have concurrent access to the same collection. In ActionScript, you cannot use multiple threads. You cannot process concurrent access to collections. In Java you can, and I'll talk about it in 5 minutes or so. So there are different collections, array list, hash map, hash table, and so on. Which one to use, you will figure out based on the needs of your project. Say you have an array list. ActionScript also has array list, right? Array list, customers, new array list. You create an instance of an object customer and you add it to the collection. You create another customer and you add it to the collection, and customer 2. In Java, you can add only objects to the collections. When you create a new collection, in this case array list, optionally you can specify what should be the initial size of the collection. In this case, if I specify 10, it means I want to create an array list which will be capable of holding 10 elements. But as opposed to arrays, which you cannot change size later on during the runtime, with array list you can. If you want to add 11th element, the size of the array list will be doubled, and then you can keep going. Hash table and hash map are storing key value pairs. For example, look at this pink rectangle. New customer David Lee, new order, new portfolio. I created 3 instances of 3 different objects. And I create a hash table, a collection special type, which allows you to store everything as key value pairs. In this example, what I do, I put the object customer, I created it on the first line, into this hash table, and I want it to be known under the key customer. I supply a reference variable ORD that points at the order instance, and it'll be stored under the key order. And the same thing I do with portfolio. If I want to retrieve an object from a hash table, I do it as I show you over here on the right hand side. I say data.get, and I specify the key. See that key order over there? So I extract the object of type order. In this case, I am casting to order, because I know that under this key I have an object of type order. There is something called generics, and I will mention it pretty soon, which would allow me to create collections which will know what data types are sitting there. At the end of the slide, I write that hash table is synchronized and hash map is not. There's the difference between them. What does it mean? You will understand when I will talk about multi-threading and situations when more than one thread is trying to access the same object or the same collection in our case. And let's talk about generics. I probably didn't mention, but array list in general is capable of or was created for storing any objects. You can put any objects in array list. One of them, or a hash table, the same thing, by the way. But if you want to use help of the compiler to make sure that by mistake a programmer will not put in the collection that's supposed to store customers an order by mistake. If you want to enforce this checking, then you can use so-called generic notation. Guys, you should understand that we have very limited time today. And of course, the topic of generics is a lot larger to cover it in detail. But at least I want to give you an idea. And later on, if you want, go and dig deeper and deeper and deeper. So what does it mean? If I'm declaring a variable and I put parameter for the class, classes also may have parameters. In angle brackets, I say, I want to declare a variable customers. And this is going to be a collection. And this collection is intended to store only the object of type customer. If I do this, and over here look at these two angle brackets. If I do this, compiler will make sure that I will never make a mistake in my program, and I will never put something wrong in the collection customer. Let's see. I create a new customer, David Lee. I added it to the customers, no problem. I created another instance of the customer, Ringo Starr, and I added without any issues. But I, on purpose, I have in here, I create a new instance of an order and want to add it to the customers, which is pretty stupid. But I want to demonstrate what's going to happen. Compiler will catch it and will say, what are you doing? You said that the customer is supposed to store only customer instances, and you're trying to put in their order. So this generic notation helps you to make sure that compiler will catch these kind of errors on the compilation stage. Demo of generics, and I wrote lesson 15 real quick. Let's do that. Closing this lesson 7. Where is my book? Going to the book, lesson 15, download, find, done. Go back to Eclipse. Right click, import. Existing project, next. Archive, it was a zip file. Let me do this, lesson 15 dot zip, right there. Finish. Lesson 15. Test generic collections. Look at this. That's code that I was talking about. So first I have commented out code, and I have this array list customer. By the way, take a look at this. Up till version 7 of Java, you were expect to put the data type in both sides of the equation, here and here. Not anymore. You can just use empty. They call it diamond, empty angle brackets, so it doesn't have to be repeated. Let's see what happens. For now, I created an array list, and I created a couple of customers and put it in there. No crime. It's supposed to work. Run. All right. Inside the customer and do something. Do something. It's here. See, void do something, and I'm inside the customer. All right. Now let's do this. I will uncomment this bad code, line 16 and 17, on purpose. I'm trying to put in there new order. It gives me compiler. Look at this. The method that customers into type array customer is not applicable for arguments order. It says you cannot do this. See? Generics in action. Let me remove generics real quick. If I remove generics, it means that this array list is capable of storing any object. Save. Oops, no error. Now it allows me to do these stupid things such as adding orders to the array of customers. So that generics at the speed of sound. If you have questions, please ask. If you don't, do you have any questions? No questions. I am a great instructor, and you are great students. That's why. That's why. Multi-threading. Let's talk about this feature, which does not exist in ActionScript, but it's really useful. In many cases, you can execute a task in parallel. Think about this case. Let's talk about the works with different servers. Say you're creating a portal. Top portion of the portal is supposed to show you the latest news from Google, maybe. The bottom portion, or the latest market news, financial market news. The bottom portion of your screen is supposed to show you information about your portfolio. Say you have some account in a brokerage company, and you are connecting to completely different server. So one, for the top portion, you need to connect to the news server, market news. And for the bottom portion of the screen, you need to connect to a database server. Completely two different machines physically. Do we have to wait? Say the information about the market data takes 3 seconds to retrieve. And information about portfolio takes 2 seconds to retrieve. So if I'd be doing everything in sequence, I would need 3 seconds for market news and 2 seconds for the portfolio. Total 5. But why? If I can do these things in parallel, so I can start 2 threads of execution which run concurrently, in parallel. This is what it means, concurrently. Thread is a lot lighter than the process. I'm not starting a task. I'm not starting 2 separate programs. They are running within the same program, but they are running in parallel. We use this word spawn. You can say we can start, of course, different threads, or you can say we can spawn multiple threads. And it will make your program much faster. If I can start 2 threads, one will run and grab the market data, and at the same time the other one will run and grab the portfolio using absolutely different CPUs or different machines, then the total time of execution will be 3 seconds, maybe a little more, whatever the slowest thread is. But it's much better than 5 seconds in case of sequential access, correct? All right, so what about one machine? Say you have only one computer. Would it make sense to use multi-threading in there? Of course. Of course. My MacBook has 4 CPUs. 4 already. So task can use different CPUs. Think about I just recently purchased this Nexus 7. This little tablet. This little tablet has, what does it have? Yeah, I think 4 CPUs and 12 GPUs for graphics. Another 12 processors. Of course, it is expected that people know how to program these parallel CPUs, but think about it. Think about this power which we can get if we will be programming in parallel. So even on the single CPU machine. As a matter of fact, it's very difficult to find a person unless you found somewhere in the attic a 10-year-old computer. It's very difficult to find a person who has a computer with a single CPU these days. But even if you do have a single CPU computer, still it makes sense to use multiple threads. Why? Even with a single CPU machine, these parallel threads of execution will compete for time, and they will grab slices of processor's time, and it still can make your program work faster. For example, one thread needs to calculate something, the other thread needs to write or read something from the disk. If you will give the time one to one and the other, or maybe another thread is asking for a user's input, why wait? Meanwhile, while the person is thinking of what should I enter, the other thread is writing something on the disk or reading something from memory. So even with a single CPU, using multiple threads makes sense, makes the program run faster. How do you create threads in Java? There are different ways of creating threads. I know of 3, but let's look at some of them. The easiest way is to extend thread. I'm using the same example. Market data thread and portfolio thread. Market data, say, grab the data from somewhere. Of course, I won't do this. I create a super simple code because my goal is to deliver the message, to explain the idea of threading, not to actually grab the market data. Say we have a market data class, extend thread. So if you want to create your class that can run as a thread, what you can do, you can say that your class extends thread. Now it has a constructor you can specify the thread name if you want, and importantly, you have to use a method run. Whatever logic you want to put for this class market news, for example, go and connect to market news server and grab the data from there. You have to put inside the method run. So green one is the market news, and on the pink rectangle I have class portfolio that extends thread. It also will run as a parallel thread. And I hard-coded some output for portfolio, of course, instead of writing some complicated business logic. So I got two threads, two classes, two threads. How do I start them? Important, pay attention. The class has the logic in the method run, right? Now look at the blue rectangle. The starting program. The program is a method main. I'm starting the program, and I create a new instance of the class market news. And look at this. I call the method start on it. Not run, but start, which is unusual, but get used to it. The method start is created in the superclass, and internally the method start will still invoke your method run. So don't get confused. This is the way it is. So you start the thread, and the program does not wait. This is important. You start the thread, and the program in blue keeps going. The next thing what I do is I create a new instance of portfolio thread, and I start portfolio. So I started two threads, and then in this case I print that they are finished. But what I just did, I started two parallel threads of execution. Of course, these threads are super simple, but imagine that market news, as I said, takes 3 seconds and portfolio takes 2 seconds. Total program would take not more than 3 seconds in this case. So that's the way how to create threads by subclassing the class thread. Second way of creating threads is different. You may have a situation when you cannot subclass any class. By the way, I never mentioned, but it goes without saying that Java does not support multiple inheritance. So you can inherit only from one class. And there are situations when you have to inherit your class from something else. And that's why you cannot afford to write, to extend it from the thread, because it's already extended from something else. In these cases, there's a different technique for creating threads. You can say that your class implements runnable. Again, it may extend something else, but it also implements runnable. If your class implements runnable, you have to implement the method run. Again, the same story. You have to have a method run if you are using subclassing thread or using interface runnable. So I'm just showing you a different way of doing the same market news and portfolio, second version. But the technique of creating an instance of thread is a little bit different if you are using interfaces versus subclassing thread. So in this case, you create a new instance of market news 2, for example, but at this point it's not a thread yet. So you have to create an extra step. You have to do an extra step. You have to physically create a new instance of a thread class and give your class to it. Your class that implements runnable. The rest will work the same. Again, you call start. You go through the same procedure for portfolio, new portfolio 2, then explicitly you create an instance of the class thread, and you give your port 2 as an argument, and then you do start. The result is the same. So two different ways of creating threads. It's not the only two, but two that we know so far. Sleeping threads. You can say to your thread, sleep for a little bit. Maybe a thread waits for some important event to happen. And it can wake up and do some checking. Did it happen? Yes, no. If it didn't happen, you can put it to sleep again for some time. So there's a special method called sleep. And if I use sleep 1000, it's in milliseconds. It means put it to sleep for 1 second. So it'll sleep, it won't bother any CPU, and then it'll wake up and do whatever. The processing will continue from the line after this sleep call. In this example, on the green rectangle, you see that I run a loop, 10 iterations, and I run a loop, I put a thread to sleep, just emulating like as if is doing some processing for a second, as if, just to show you. I will run this example so to illustrate something. But anyway, 10 times I run this loop, and every time I put it to sleep for a second. Of course, it'll sleep total to 10 seconds. So it'll sleep, and then it'll print the market is improving and the value of I. On the pink rectangle, I do the same thing with portfolio, but what I do, with portfolio, I put the thread to sleep not for a second, but I put it to sleep for 700 milliseconds. 700 milliseconds is less than a second, right? So I want to emulate a situation when I will start 2 different threads. Each of them will sleep awake, but they will sleep for a different time, and they will awake at different time and print their messages. As soon as it'll be awake, it'll print its own message, and this one will print its own message, but different time. The running program is the same. Test thread 3. I'm starting the first thread and the second one, but now they are running in a loop. And we will run this program, and you will see what happens. You will see what happens, how they will run in parallel, and they will print at different time. Before we run the program, I want to explain you something else. Or maybe I should run a program first. Lesson 20. Let me do a demo of thread first, and then I'll go back and explain you what is thread synchronization. Lesson 20, I need to import, right? Let's do that. In Eclipse, right-click, import. Existing project, browse, lesson 20. Lesson 20. What do I need? .zip. It's getting dark over here. I will need to step for a second and turn on the light. Let me close this stuff. I don't need all this. Lesson 20 is this little example with threads. Let's open up this guy. Actually, let's open up the first one, the very simple one. Right click, run as Java application. Works. It uses portfolio, which is a thread that extends thread. It uses market news, which extends thread, and it runs them in parallel. The second version of portfolio is not extending thread, but it's implementing runnable. The second version of market news is not extending thread, but it implements runnable. Accordingly, the second version of test thread uses a little bit different technique of creating these threads. Let's run this second version. It works the same way. Now let's look at the third version, Market News 3. I added these loops. By the way, look at this. I am using this try-catch block, similar to ActionScript. Try-catch block in here as well. And why did I do this? Because I'm using sleep method. The sleep method in Java may throw an exception. In particular, it may throw interrupted exception. That's why compiler forced me to put it in the try-catch block. So this one, market news, will sleep for a second, and then it will print market is improving and the value of I. And the portfolio 3 is the same thing, but it'll sleep for 700 milliseconds. and it'll print you have 500 shares plus IBM. Test thread 3, it's very simple. Starting these two threads in parallel. Let me run it. Look at this. Two threads are running in parallel. So what can we see? What can we see? First of all, a little unusual thingy. The main method was finished technically first, right? Look at this. The main method of test 3 is finished. I started these two guys, and they are living their own lives. My main method is done, but these two threads are still running. They are loops with sleeps, right? Who was first? The portfolio finished first because it was sleeping shorter period of times, right? And then I still had the first thread about the market news was running for three other iterations. Check this out. In couple of cases, I can see that the IBM was waking up twice. It was sooner than portfolio. This example just shows you that they are really running in parallel. They started from one and only task, test thread 3, and they were running in parallel. And this is multi-threading in action. Of course, it's a simple example, but it's very, 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 very powerful feature of the Java language. Now let's talk a little bit about thread synchronization, but just wait for 10 seconds. I turn on the light because it's getting dark here. I'm back. Let me explain you what is race condition and what is thread synchronization about. A race condition may happen when multiple threads are trying to grab the same resource. And here's an example which you will definitely understand. Let's talk about a husband and wife. And they are located now in two different locations. They are trying to withdraw cash from two different ATMs at the same time. They have one account, joint account. And what happens? Let's say they have $100 in there on the account left. Each of them wants to buy something. A husband wants to buy something for $70 and wife wants to buy something for $50. And they know that they have $100 on the account. Now think about it. Each of them is inserting the card in the cash machine by accident. Technically in the same time, maybe a millisecond or 10 millisecond difference. So what happens? The bank supposed to connect to the database server, check how much the balance, how much of a balance left on the account, and first action is check the balance. Second action is deduct the amount they want to withdraw from the machine. So there are two actions to the same resource technically. Say there is a server-side Java program that's supposed to do this. Now let's consider this situation. Husband was first. His request to check the balance was first, and he wants $70 and they have 100. Nice. And between the withdrawal and the wife's thread, which was checking the balance, actually the wife's thread cut in and it also checked the balance. What happened? Yeah, there is $100 because withdrawal of the husband didn't go through yet. So the wife's thread checked the account balance and also got an okay to withdraw money. Next comes the husband's thread and withdraw $70 from the account, leaving 30 in there. But wife's thread received okay to withdraw as well. And she wants $50 and there's only 30 left. So we got a situation called race condition. multiple threads coming from different locations. In this case, we're trying to modify the same resource. We had a concurrent access, so we have to protect it somehow. We have to place a lock on a resource that can be accessed by multiple threads, as in my example. So, and this is what they call synchronized access or not synchronized access. Of course, if we place a resource, husband threads grab the resource, and until it checks the balance and modifies the balance, no one else can get this account. If we would do it this way, then we wouldn't run into this problem. So there are different ways of approaching it. In Java, originally Java came up with this keyword synchronized. If you have a suspicious code in your program that might be accessed by more than one thread, then in this case, please put it in the synchronize block. Synchronize would place a lock. Starting from Java 5, they came up with a better utility to place lock which is not that damaging. By damaging, I mean, of course, you want the program to work as fast as possible. So you want to make sure that the time when you keep a lock on a piece of code as short as possible, to the bare minimum. So they came up with a more efficient locking of these resources, and there's a special class called reentrant lock. And actually they came up with the entire package in Java 5 called Java Util Concurrent, with a bunch of classes that are optimized for multi-threaded environment. And if you will ever work with multiple threads, most likely you're going to be using classes from there. I'm not going to go in too deep because we don't have much time, of course. All right. Next, I already mentioned that we have to minimize the locking period. Again, I will not go too deep into details, but the example on the left is placing synchronized keyword in front of the method, basically locking the entire method. Until the entire method is finished, no one else can call it. But what may happen that this method has some innocent code that wouldn't cause any problems. So the example on the right, which is on the pink, no, it's not a pink, it's a lilac or something, purple. This example is placing a block on smaller portion of code, not on the entire method, but on the smaller one. So the idea basically is, if you are placing a lock, keep it on the during the shortest time as shortest time as possible. And this Java Concurrent has so-called executor framework, which has a whole bunch of classes that are created for working with threads. And one of the interfaces that I would recommend you to look at if you will ever learn the threadings deeper, look at the callable interface, which is another way of creating threads. It's too advanced of a topic to cover it today, though. I did use a demo. Java annotations. In ActionScript, you have so-called metadata tags, right? In these square brackets, you can put some metadata in front of a class, for example. In Java, there is a different mechanism, and in Java, it's much more powerful than these metadata in ActionScript, and it's called Java annotation. Data about your data. So annotation starts with @. First of all, Java comes with a whole bunch of annotation. You can annotate classes, you can annotate methods, you can annotate class variables in there. And if you are using annotation, they mean something, of course. For example, if you, at this point I'm talking only about the annotations that come with Java. For example, if you will put this annotation override right above a method, this means that you are planning to override some method from the ancestor. You can say, why do I need to bother? I remember that I wanted to override this method. Of course you remember. And if everything is fine, you don't need that. But if not everything is fine, what if you make a small mistake? You you were planning to override it, but you made a mistake, and instead of 2 arguments, as it used to be in the superclasses method, you put 3 arguments in yours. It's not a mistake. It's a method overloading, right? But you wanted to override, and you wouldn't know that you did something wrong. So if you will put an annotation override in front of the method, compiler will help you. If you will make this mistake, compiler will tell you, what are you doing? You said that you want to override the method, but you declared the method with an extra argument. So these are so annotations start with that sign, and of course this is just the tip of the iceberg. You can create your own custom annotations, and it's pretty powerful mechanism. Most likely, or I would say 90% of the Java populations do not create their own custom annotations. But it is possible, and definitely who is using these annotations, whoever creates some frameworks for Java. They definitely use it. And on the Java EE side especially, they also use annotations heavily. That's super brief overview of what is annotation. I already mentioned override. So this is an example of using override annotation in front of the method called text. So if you have a class nj_text which extends text, and if you are planning to override the ancestor's method called text, you can annotate it with this. And in this example, if you by mistake will put an extra argument in here, see, the superclass doesn't have any arguments in called text. But if you will make a mistake and if you will put an argument in the green for the method called text, compiler will stop you. It'll tell you what are you doing. You are overriding, you are not overloading. And on the pink rectangle at the bottom, I show you exactly that. If you will try to add an argument in here, compiler will give you an error that you must override. You said so. Annotation. You can create custom annotation, as I said, but we have no time to even think about it during this course. If you decide to learn it, there's tons of information. You can read my book, of course, and you can read any other books that you can grab. And there's tons of free online tutorials. And final portion of the presentation, I want to tell you just a little bit about the server side. About the server side and specifically about this presentation tier. What is this scary slide about? Remember I said in the beginning there is Java SE and there is Java EE. Java SE is mainly for development on the client side or standalone Java programs, and Java EE offers you a whole bunch of different technologies that could be used on the server side. So on this slide you have different tiers. Of course, client tier could be programmed by anything that you want. Since you are Flash or Flex developers, then of course in your case you'd be using Flex. Flex can talk to the server side using all these different HTTP requests or maybe AMF protocol in case of Flex, but somewhere on the server side there should be a servlet container in the presentation tier with deployed BlazeDS, or maybe not. Maybe you want to just create an HTTP request to a remote server, or maybe you want to use web services, RESTful or SOAP. So clients have a choice. As to the server side, there are different ways to architect the application. Presentation tier is a place where you put something to prepare the data for the web applications, the data to present to the user. Typically, you don't put much of a business logic in there, just preparing the data and sending it to the browser. There is another tier called business tier. Java EE, and 6 is the latest version of Java EE, suggests using Enterprise Java Beans on the business tier. The third-party companies offer their frameworks to use instead of business tier. It's up to you what to use. We will not be discussing pluses or minuses of using or EJBs versus, say, Spring framework. And of course, somewhere you have to store the data. So there's somewhere a data tier. Maybe you store the data in the database management system, maybe you use messaging, maybe web services and so on. We will not even go there. We will just touch a little bit this presentation tier. And what Java offers? Java offers servlet container and Java servlets. If you are Flex developer and if you will decide to use BlazeDS or LCDS on the server side, this is where you would put it, in a servlet container. For example, in a Tomcat or in Jetty or in any other servlet container that your company is using. But the point is, you have a web browser. In your case, you'd be having Flash player inside as well, right? But say we are in a Java world only, maybe Java, JavaScript. Regardless, the client is issuing HTTP request. HTTP goes to the web server. Web servers try to check, is this a very simple static request where they are trying static resources? No, for example. Then in this case, it'll forward this request to the servlet container, to Tomcat, and you may have a servlet in there that will process your request and maybe pass it over to the other tiers. Maybe it'll work for the database, maybe it'll be using messaging, or maybe web services, or maybe Pojo, plain old Java objects. Could be. But we will not go that far. We will be talking about a servlet, Java servlet. This the one which is sitting over here in the presentation tier, the first tier, so to speak, on the server side, which will get your request to process. I will be talking about Java servlets as you create them as a developer. I have a couple of slides at the end regarding BlazeDS, but we will not spend too much time on it. It's a Java presentation. So how do you write a servlet? You need to write a Java class that extends a servlet. I want to repeat, I'm talking about server side now. And what you need to do, you need to annotate your class with @web_servlet annotation. And then your servlet container will know what to do with it. Depending on how you send your request from the front end, if you are using method get or post, and as a matter of fact there are some other methods as well, you will need to program on the server your business logic either on the doGet method or in the doPost method. That's the rule. And the first servlet looks like this. Where is your class? This is a class. Say, for example, you have a class that's supposed to find books. You write a class, find books, and you annotate it with this annotation web servlet. And you specify to this annotation some parameters. One of them is URL patterns. You may have more than one servlet, of course, deployed on the server. Which one should be invoked? And this URL pattern says, if a URL has the word books in it, this is a servlet to process, find books. You may have other servlets, but they would be mapped to different URL patterns, and this is how the servlet container will know which one to call. As I said, depending on where you are, what kind of request you receive from the browser, in this case, I show you an example. If the browser sent you a GET request, in that case, you need to write your logic in the doGet method. So all the processing will be going here. The servlet, every servlet in Java has two arguments, request and response. And the reference to this object will be given to your class by the container, by the servlet engine. So whatever came from the user, from the web browser, will be available for you through the object request, through this argument request. On the other hand, if you want to send something back to the web browser, you will need to shoot it through the response argument. In this example, I'm showing you how to get a reference to the stream that points at the user. You can write response.getWriter and then out println hello from find books, for example. And this hello from find books will be sent over to the web application. Sorry, to the web browser, to the client. Client will see hello from find books. To deploy a servlet, of course, you will compile it, and you will need to put it in the appropriate directory, which depends on what server you are using. If you are using Tomcat, this would be a directory called web apps. You need to read documentation on the particular server. If you'd be using Glassfish, for example, which is another server from Java, you'd be using domain name and document root. But regardless of where you will deploy where you copy your compiled code, the structure of the directories on the server side must be the same by the spec of Java EE for the servlet. It will contain a couple of directories in there, and here's an example. Say we know that we are using Tomcat, so the document root directory for Tomcat will be web apps. Under this directory, though, you will be creating directories for your applications. So if you want, you can put everything under web apps, but most likely you're going to be creating subdirectories. But every subdirectory is if you have a subdirectory for your application, it'll have web-inf and maybe meta-inf, but web-inf definitely. Inside web-inf, you can either deploy your servlet as separate files. In this case, it's an example of a servlet that was created in a package com practical Java lesson 27. Or you can jar them up. You can combine them in the so-called jar files. Jar files it's like a library. And you can put the jar file, if you have many Java files in there, under lib. And this is how you deploy them. So by having the same structure for every servlet, for every spec, you may deploy or redeploy a servlet under different servlet containers. Say you decided to work with Tomcat first, and then you change your mind, and you decided to go and work with Jetty. It's a popular container as well. Or with JBoss, or with Glassfish, or with WebSphere. So by having the same standard structure, redeployment of a servlet is pretty easy. I will not be doing the whole demo. These slides will be available, and if any of you will decide to do that, but I will show you just the beginning of this demo. And this is the situation, and this is the moment where we want to use Java EE perspective. Remember, I said in the beginning that you should be downloading Eclipse for Java Enterprise Developers Edition. Eclipse for Java EE edition. So I will switch to this Java EE perspective for a moment. Let me close all these files which I don't need. In Java EE, which comes with a special nice plugin for web applications, I will say that I want to create a new project, but it's going to be a special project. It's called Dynamic Web Project. If you don't see it right away in this menu, you can go to Other, select the section Web, and in the Web section you will find this Dynamic Web Project. Click on Next, and it'll create a Dynamic Web Project. Now the next question is, where do you want to deploy your project? Of course you can give it a name, but it needs to have a target runtime. You need to configure a server, which I don't think I did. There is a special view servers. You need to tell Eclipse where exactly is your server. And if you will configure Eclipse, then you will be able to start server and stop server without the need to leave Eclipse at all. How to do this? While sitting inside the server view, you can do right click and say new server that you want to configure, or you can click on the menu File and click on New and find a server in the other menu. I have it in the servers view, so right click New Server. I want to configure a new server. Which one? There's a whole bunch of them, different ones. I have downloaded Tomcat 7. I click next. In my case, does it know where it is? Apparently I already created, I specify it recently, and I just reusing it. But if you would be using absolutely brand new workspace, it would ask you, tell me where is your Tomcat installed on the disk. In my case, it's skipped it because I'm reusing the existing workspace, and in there I was already defining or configuring the server. See, I started Eclipse, and I can stop Eclipse, and I can deploy projects under Eclipse. So if I will create a new project, new dynamic web project. Now I'll say test servlet. Now I'm creating a project for the server side, and I want to name it test servlet. It asks me, where are you planning to deploy it? I may have multiple servers configured in my Eclipse, which I don't in this case, but I could have. So I say I want to use Apache Tomcat 7. Fine, next. Directory src, where to compile files, next, and finish. Now it creates a special project that is ready to be, that simplifies your deployment. See how much stuff is in there? In particular, there is a folder called web content of the proper structure. As I said, so I can create servlets in here or any other classes, and they will be properly deployed under the web-inf directory, which for now has nothing but empty lib. If I will finish it, if I will finish the deployment, then if I will finish writing the project, I can deploy it. How to deploy it? You right-click. For now, my project is empty, as you know. But if it wouldn't, then I can click on the server, Tomcat, right-click, add and remove. See, I have only one project on the left-hand side over here that was created originally to be deployed under the target runtime, Apache Tomcat. That's why I can. I see only one over here. The other one, lesson 15, 20, and 7, they were simple projects. They were not even dynamic web projects. So how to deploy a project? Very simple. You select the project, you press the button add, and you finish. So the server is publishing the new project, and see, I have test servlet in there. There is nothing there, but I deployed the project, and Tomcat knows about it. Now, if you want to create a servlet, you do right-click in this project, new servlet, give it a name, say my first servlet, next. It asks you the mapping. What should be in the URL that should invoke this servlet? In this case, it automatically gives it the same as the servlet name, but I can edit it. Say I want to use the word books, just as in slides, or book. Whenever there is the keyword book, the word book in the URL, I want this servlet to be used. Next. It asks you, and which method do you want me to generate? I say I know that I'm not going to be using post method. I don't need any constructors, any of these. No, these I need. Do get. I'm saying generate for me do get, please. Finish. Done. The servlet is ready. I mean, it's empty, but you can write your business logic over here, and in the slides. I told you what to do, I told you what to write, and in this case I said do all that, and in here I said please do this. Grab a reference to the output stream for the response, so you can send something to the client and print in there hello from Findbook. So if you will finish this exercise, then basically you would need to copy it over here, this code from the slides, instead of this. Actually, you can do it. You can replace this commented line with we have this variable response, get writer. Print writer, say out equal response. I'm saying to this response, give me a reference to your stream so I can talk to the user. Response dot get writer. And then I will say out dot print. What do you want to print? Hello from Findbooks, but you can print, of course, anything. Hello from my great servlet. Now it doesn't know where the print writer is, so you need to import it. It suggests the Eclipse. So do you want me to import it? Yes, I want it. Save. Done. That's it. The servlet is ready. The servlet is ready. The servlet is deployed, but the Tomcat is stopped. Let me restart it. I restarted the Tomcat with this servlet, and now what I can do, I can run it. Java resources under SRC should have my servlet. Not here, this one. Right click, run as, run on servers this time. Which one is your existing server? It knows that it's mine. Always run it. You can click on it. See? The servlet responded. This is the URL. This is the URL that was running. If you want, you can copy it into the external server, into external browser, sorry, and hit it there. It responds. So my server Tomcat was started from Eclipse. Under this Tomcat, I had deployed project, and this deployed project was a servlet, and it's still up and running, so I can hit it from any location as you want. And it responds. That was a servlet. Pretty easy and powerful. What happens is, to finish this presentation, just 2 slides more and we are done. What happens is, when you use Blaze.ds, for example, from Adobe, Blaze.ds comes with its own servlet, and it's called Message Broker Servlet. So every request that comes with your Tomcat, for example, if you install Blaze.ds in there, will be routed to this Message Broker Servlet. It'll grab it, and it'll pass it to your class that you will configure. Which class you want to configure, you will need to configure the destination in the, say, remote config XML that is a part of Blaze.ds. So you will hit the server with your Flash player and remote object, for example, request. Blaze.ds is deployed under Tomcat as a servlet. It will grab it, pass it to your class, yours or whoever writes Java for you. And Java will do the logic and Java will respond. So we have this AMF communication back and forth between the Flash player and Blaze.ds running under the Java container. And Eclipse, if you have Eclipse and Flash Builder installed, you can create combined Flex Blaze.ds project. Pretty simple. I explain it to you over here how. And these are the configuration files from Blaze.ds. As you can see, it is Blaze.ds itself is deployed as a web application under your project that you would create as dynamic web project in Eclipse. I think it's way too much information that a normal person can handle. So I can call it a day, and if you have any questions, please let me know. In any case, I'm gonna make this presentation available, so if you guys want to look at it later on, fine. All right. So I'm glad you liked it. You are welcome, and good night is getting really late. Thank you for coming. Thanks a lot.